Now that you're familiar with using a U substitution to evaluate an integral, we're going to use it for definite integrals. At the end of this lesson, you'll be able to use a U substitution to evaluate a definite integral. And by definite integral, we actually have limits, so we're going from 0 to 1 this time. And there's just a little bit different way that we'll work the problem, so I will show you how to do it. All right, so if I have this problem right here, the first thing that I am going to do is I'm going to go ahead and perform a U substitution. So we're going to go ahead and let the information that is inside of the parentheses be our U. So we're going to let U equal x squared plus 1. And then we'll take the derivative. The derivative will be 2x dx. I notice I'm just going to rewrite my integral here. When I go to rewrite my integral, I have, this will become U. And there's no power, so it's still just going to be U. And then I notice that I have x dx, and this says 2x dx, so I need a 2, which means I need to put a 1/2 on the outside. So I still have the 1/2 out there. Now the 2x and the dx I'm going to cross out because they are going to become du. Right, now before I evaluate the integral, notice I had limits of 0 and 1. Those are x limits. So what I would like to do is actually change the 0 and the 1 to being u limits instead. So we're going to put u equals, for the 0 one, you're going to put 0 in for the x. So 0 squared plus 1 is 1. So that new limit instead of 0 is going to be 1. And then when x is 1, we're going to get u equals 1 squared plus 1, and that will equal 2. So my new limit is 2. So now notice how we totally just changed the problem. And now from here, we are going to actually take the integral. So we're going to have 1/2. The integral of u will be 1/2 u squared. And then from here, we'll get 1/4 u squared. Now, if you remember from here, I'm not going to put the u back in because I changed the 1 and the 2 to u values. So I'm just going to keep it with a u in it. Okay, so when I plug the 2 in, we will end up getting, let's see, this 1, and then minus, when I plug 1 in, I'll get 1/4. So my answer will be 3/4. Okay, I do want to show you another way that we could have approached it. If we had left this, we would have 1/2 integral of u du. Let's say I just pretended like the limits didn't exist for right now. My integral would have been 1/4 u squared. I could have substituted back in, and I would have had 1/4 x squared plus 1 squared. I would have to evaluate it at the original x limits, which would have been 0 and 1. If I would have plugged in 1, let's see, if I plug in 1, I will get 1 plus 1 is 2, 2 squared is 4, I get 1, and then minus, if I plug in 0, I still get 1/4, and notice I still get 3/4 is my answer. Okay, I like to do this way that I did on the left because it just saves me a little bit of substitution work. So I prefer that way, but either way is doable. So let's try another example, and let's see how we do. All right, I do know that this is a u substitution problem because we have this square root going on. So I'm going to let u equal, let's see here, 1 plus 2x squared. The derivative of u would be 4x dx. I notice that, let's just start replacing my parts here. This stuff down here I could replace with u, so it's going to be u, and actually I'm going to put, this is going to be u to the negative 1/2 because it was a square root. And then I have x dx. I'm supposed to have 4x dx, so I'm going to place a 4 in that place, which means I have to bump a 1/4 out front. So I still have the 1/4, and now I should have scrolled that out. Here, my 4x and my dx both get replaced with the du. And then again, from here, since I have my 0 and my 2, I'm actually going to be replacing those. So when x equals 0, my u will equal 1 plus 2 times 0 squared, which will give me 1. So it's going to start at 1 now. And when my second u, again, 1 plus 2 times 2 squared. 2 squared is 4, times 2 is 8, plus 1 is 9. So now it will go to 9. So now I'm going to go ahead and perform my integration. The integral of u to the 1/2 will be, negative 1/2 will be u to the 1/2 times 2. So this will be 1/2 square root of u. And since I changed my variables, I don't need to substitute my u back in. So I'll just put 9 and 1. So I'll get 1/2 times the square root of 9, which is 3. So that will be 3/2, minus, if I plug in 1, I get 1/2. 3 halves minus 1 half would be 2 halves, which would be 1. And then I will go ahead and work it out the other way just in case you wanted to see it. I could have gone to this step right here and we would have still had 1/2 square root u, but then I would have substituted the x back in, the u back in, and then I would have evaluated it at the original 0 and 2, and then if I still plug it in, I still will get a value of 1. So it really doesn't matter which way you work the problem. Again, I prefer this way. It just cleans it up a little bit, but you can decide either way will get you the right answer. So hopefully now you can use a u substitution to evaluate a definite integral.